carbon, 2. Ground. The greenhouse effect, which is causing climate change, is a threat to nature's ecosystems, endangering the existence of human mankind on Earth. Ice caps are melting and the sea level is rising. Extreme weather conditions are happening more often. Deserts are growing and people are starving. Diseases and epidemics occur more often. Wars about fertile land and water access are becoming more likely. Although the consciousness about this problem is growing, and more people are working out ways to reduce the greenhouse gas emissions, we urgently need new tools for addressing this problem. So let's look at some tools you may not have heard of yet. There are several different greenhouse gases, like methane, nitrous oxide, and most well known, carbon dioxide, also known as CO2. Although it is not the most harmful of these three gases, it is the one we emit the most by far, so it is a good one to start with. In addition to reducing our CO2 emissions, we have to start actively filtering out some of the CO2 that already is in the atmosphere today. It is already possible to capture CO2 directly from power or production plants and to lock it away underground in a liquid form. This is called geosequestration, and while it may be better than nothing, it is not the most clever solution, as there are no long-term studies about negative consequences of the process. Also, the liquid carbon dioxide is usually not used further as a raw material in this expensive process. When we look at nature, there is no such thing as waste. Every waste product is constantly used as a nutrient for something else. Other technologies are extracting CO2 directly from the air surrounding us, using chemical reactions. This is very expensive and to this day not very efficient. Both of these technologies waste additional energy for extracting something that should not be there in the first place. But what if I told you about a process to capture carbon dioxide from the atmosphere without the use of chemicals, while producing oil, gas, and raising soil fertility in areas where soil has lost its nutrients? It may sound like a fantasy, but this actually exists. One of the tools for all this originated thousands of years ago in the Amazon rainforest. It is called terra preta, Portuguese for black earth. The indigenous tribes in this area invented a way of raising the fertility of their soils for growing food. They mixed leftover charcoal from fireplaces with all sorts of organic waste, including food waste, plant residues, and human or animal feces. This mixture was then stored, and after several weeks they put the resulting dark substrate onto their fields, raising the yield of food production. The interesting part about terra preta is the high carbon content in it. The used charcoal is today referred to as biochar because it is made from plants. Biochar has a highly porous microstructure and is very stable for a long time. It can be made from any locally available dry wood waste and has fantastic properties for storing water and nutrients. Microorganic activities are enhanced. The highly fertile soils at the Amazon basin still exist, and they are even reproducing themselves, growing about a centimeter a year. Biochar stays in the ground for several thousands of years and is a natural superabsorber for water and nutrients. The second tool is called pyrolysis. Pyrolysis is a process of heating wood particles to about 400 degrees Celsius in a closed container in the absence of oxygen. This way the volatile contents of the plants evaporate and can be captured as gas and oil, leaving only biochar, which contains 50 to 80% pure carbon. The emissions produced for heating the process are much smaller than the carbon stored in the resulting biochar. The produced oil and gas can be used as fuel. It sounds too good to be true, but pyrolysis of wood is a CO2 negative energy source, using the energy of the sun through the photosynthesis of the used plants. The system is scalable, and there are available ovens from small do-it-yourself cookers over shipping container-sized solutions up to big pyrolysis plants. All of them extract CO2 from the atmosphere. The third tool is bamboo. Bamboo is the fastest growing plant on the planet, and botanically being a grass plant, a very undemanding one. It can grow virtually anywhere. When cut off, the plant doesn't die, but grows a new trunk instead. The strong and hard wood is a precious renewable material for uncountable applications. Some species are even edible. While growing this fast, bamboo captures more CO2 from the air than any other plant, being a real climate superhero. When paired in clever use with other plants, bamboo can give protection against wind, sand, heat, and help stabilizing riverbanks, reducing water losses, soil erosion, and surface runoff. Now imagine what could be done if these three tools were combined. For example, think of a farmer who has a field in a location with very hot or windy weather conditions. The soil is relatively infertile and dried out, so no crop plant could grow there. Now the farmer buys some bamboo plants and some terra preta from a terra preta shop nearby. There he also gets educated by the staff about how the process works. On a small portion of the land, the terra preta is mixed into the native soil and the bamboo is planted. Thanks to the water storing properties of the new soil, the bamboo soon grows to full size and can be harvested for the first time. The bamboo wood, other locally available wood waste and redundant organic farm waste can then be brought to a local terra preta facility to produce more biochar and more terra preta. The farmer can then buy additional terra preta at a much lower price in exchange. Of course, it is also possible for the farmer to produce his own biochar in a small domestic pyrolysis oven or in a bigger container-sized system, shared by several farms. The process is nearly the same as a long time ago in the Amazon rainforest. In both scenarios, the new terra preta is used to fertilize another area of the land, and some more bamboo can be planted, effectively doubling the next yield. This way, the farmer can quickly build a natural protective fence against erosion and the elements. After the fence is completed, the now available large amount of terra preta can be used to fertilize the rest of the field, and the farmer can start growing a diversity of useful plants. In addition to that, redundant bamboo wood can be sold, further expanding the economic value of the process. This principle may be applicable to restore whole landscapes and even to push back desertification, giving people food and water security, while the plants constantly absorb enormous amounts of CO2 and lock it into the ground, counteracting all the problems associated with climate change. In theory, it is also possible to build big bamboo plantations solely for the use of extracting CO2, but there is the danger that in doing so, greedy people will cut down existing vegetation for profit. This has to be prevented, and bamboo as a climate hero should only be planted on otherwise unusable land. But compared to expensive and inefficient technical applications for geosequestration, the carbon-to-ground cycle seems like a viable and highly sustainable alternative. Terra preta, pyrolysis, bamboo. A fantastic combination, and a possibility to finally repair some of the destruction our civilizations have caused to the planet.